All right. Good afternoon, everybody, and thank you for having me on XR Miami this year. I'm delighted to have moved to Florida about 4.5 years ago. There is so much going on in this region that I'm so excited. So as Sydney very graciously introduced me, I have been doing quite a lot of work in XR for the last 35 years. My first VR experience was in 1991. And since then, I was pretty much hooked on it. And of course, over the years, have been evolving quite a lot. So what I thought I would talk a little bit today is a lot of the tremendous opportunities that we have right now on the world of XR, especially with the boom of digital twin technologies, AI, and many other things that we see today. Because at the end of the day, we need to be able to interact with this very complex information in the computer. So the more complexity, the more digital complexity we add to the world, the more opportunities of all of us to remain employed, getting grant funding, getting our PhDs, we are all gonna have. So, of course, today the world is very complicated. We have a lot of changes, challenges. It's very interconnected. Things move very fast. Something happens here in Miami, and in less than a second, somebody back in Singapore knows what's happening here in Miami. We are all trying to be unique, to have a differentiator, to be very competitive. There is all kinds of things that are happening. And the common thing that I'm starting to see more and more that is bringing us together is what we are calling the worlds of digital twin. Now, when we talked about digital twin, depending on how you talk to, it's going to tell you something different. And that was a big challenge. So as part of the national academies, we got charged by the Department of Energy, DARPA, the Department of Defense, the National Science Foundation, the National Institutes of Health. So there was a federal mandate to some of us on the national academies about a year ago to say, hey, what is digital twins? We hear this term and everybody interprets it differently. So I put in here, a group of very prestigious colleagues, and I was a small part of that, spent about a year going around not only the United States, but the world, what is digital twins? What are people doing with digital twins? So how do we define what a digital twin is? And how we set up some kind of norm so people can really start operating and developing on this field. So, of course, we run into a lot of challenges because, obviously, it's a very exciting topic. It's on the news all the time. Everything is a digital twin right now. So the first step for us was kind of shifting through all the weeds and trying to figure out what the really good things. There is really not a good agreement on what it is. So you talk to some group, a digital twin is a 3D model. You talk to another groups of people, a digital twin is some computational simulation that makes a physical phenomena. There's a lot of misinformation of what all this is and how much they can do, how much is real, how much is wishes or expectations of what they can do. So again, we step up on this challenge with, okay, let's just sort through all these things and let's try to figure out what it is, and also try to come up with some sort of positive message to say, hey, it's an emerging field, there is all these opportunities, so everybody, in a sense, has a place in the world of digital twin. And realistically, yes, everybody has a place in the digital twins. So, the sort of things that we looked at, of course, you have all the data that come in through whether it's sensors or it's other forms. It's going to have some elements that are going to be some simulation, which is good old numerical computational simulation, as well as predictions, which are going to be more driven by AI. There's going to have a lot of elements that had to do with interactivity, interconnections, and so on. But one of the things that we think is most critical when we look at digital twins to the future is actually that constant live bidirectional connection between the digital space and the physical world. Because at the end of the day, they are going to be a replica of the real world. So I put in there, I'm not going to read it, this is the official definition that we gave, and it's now the official definition that has been accepted by the majority of the federal US agencies, and this is what a digital twin is in there. So a set of virtual information constructs that mimics the structure, context, and behaviors of a natural, engineered, or social system. And that was very important to us. We want to make sure that this is not an engineering thing. This really covers the entire spectrum of human life, okay? So why am I talking on XR Miami about digital twins today? So there are things that are very important to us as an XR community. So first of all, let's say the long-term goal or the long-term aspirations of digital twin is to give us centralized information. And I didn't necessarily mean geographically centralized information. I mean more logically centralized information. So when I need something, there is a single point of entry to some extent to get that information. Hopefully, it's going to help us to have a lot of speed and agility. For example, on the early days of digital twin, when the word digital twin didn't even exist, I was doing some work on the automotive industry. So their process from product concept to product on the street was 9 years using their traditional engineering processes. When we start introducing digital twins, which again, we were not using the term digital twins on those days, we reduced that to 2 years. So we went from 9 to 2, concept to product on the street. So the potential for that kind of thing at a much broader range in many other industries is tremendous. Related to that, of course, effectiveness and efficiency, because there is a lot of sort of what-if scenarios that we can do. There is a lot of pre-planning we can do, a lot of trying this, trying that, and a lot of automation that can be integrated into digital twins. Very important, and this is where we are starting getting more into the XR and visualization and interface, it gives us an opportunity to personalize that information access and information manipulation, because right now the world still operates on one size fits all. You get a software package, and it's an interface that is the same for everybody. But you know, some of us are more visual people, some of us are more numerical people, some of us are more textual people, some have more memory, some of us have less memory. So all of us looking at the same screen with very little personalization is certainly not, in my opinion, the future. And I think digital twins give us that potential for personalization. The standardization is huge. I'm sure many of you that work in positions where you have to integrate different pieces of software, different pieces of data, you know, it's not very easy. You have these vendors' products and that vendor's products, and they don't really come together. That is very, very difficult many times to integrate things, and there is a lot of effort, a lot of cost, a lot of delays sometimes that have that. So digital twins, whether we like it or not, are going to force us to really be serious about standardization. They are going to really push us very hard on that. Another benefit that they have is that it gives us a common language when we are looking at a problem. The world is very multidisciplinary today. An example of that is, for example, the oil and gas industry, where you have geologists, seismologists, which is not the same thing. You have drilling engineers, you have policymakers, you have many other environmental groups, and they are all trying to understand what's happening when a new drilling well is going in. So the languages that those people use are very, very different, but you bring them into a common digital twin. Suddenly now we have a common language that helps people understand each other better. It's going to allow us to do a lot of alternatives, a lot of studying new things, and of course has a huge potential for risk reduction, because we can do everything on the digital realm before we go to the physical world. So again, another example, I cannot name companies, I can tell you the example. So some digital twin that we have worked on recently, we discovered that there was, if we would have proceed in this particular industry with something that we're trying to do, even though traditional methods didn't discover a small oopsie that was in the process, that a small oopsie would have actually turned into pretty serious loss of life if it would have happened. We were able to identify that on the digital twin and be able to correct before we went and deploy into real life. And the correction was very, very simple. It was just a very tiny detail, but the propagation impact through the workflow had a pretty big impact, potential impact at the very end. So really what we care is about, I'm a systems engineer by training, so I always talk about, it's going to help us to answer all these questions at the same time. What am I doing? How am I doing? Why am I doing this? When am I going to do it? Where do I have to do it? And so on. Because we tend to think differently. So some people answer the what, some people answer the why, some people answer the how. And again, the world is starting to be too complex and to interconnect, and we need to address all those things at the same time. So the challenge is, okay, I have this wonderful, magically built, we don't know yet how, digital space that represents something in the physical world. So now, how do I access that? So what are we doing today to access digital information? Ta-da! Dashboards. We are all in love with dashboards, aren't we? So we like that. I call it the French doors to digital twins because you actually have this little grid quadriculated thing, and some of them, as you can see on my images, are starting to get very ridiculous. So I am deaf to the dashboards, to be honest with you, and that's what I'm here today, because dashboards, I think some of us forget what dashboards were created. They were not created for everyday use, in case some of us don't know about that. Dashboards, first of all, were created to be your weapon. We're using them today to be the weapon of choice for data analysis, okay? Everything is a dashboard. You start a project, and I just cringe my teeth because when you have the whole design team, and the first discussion is like, oh, we're going to design a dashboard. And I'm like, we don't even know what I'm going to do, and we're already talking about a dashboard. I mean, I don't even know if I'm going to use a dashboard. I don't know. I'm trying to figure out what I'm trying to do. But to me, what people forget is that dashboards were created to give very condensed information very quickly to high-level executives. So you work for days, for weeks, for months, for years, and you got 5 minutes of your CEO, 5 minutes of your board of directors. That's what a dashboard is good for, because now you condense all your work, extract the most meaningful information, and assemble it into 1 or 2 pictures that are very high level, so they can make that final decision without worrying about the details. That's what a dashboard is for. It's not an everyday tool. It's not your weapon of choice to deal with data. It's a piece of very high-level synthesized information. But we still use them a lot. Because of that, a lot of these dashboards tend not to be actionable. So if I'm looking at the dashboard, and I have a question about the data that is being displayed on the dashboard, I might have to call my programmer and say, hey, add another pie chart to answer my question, because I cannot just click on the little something and enter something and ask some questions. I guess with exceptions, some people do that, but generally, there are more like an output piece of information than an input information. And the other thing that is very critical, and again, very relevant for all of us here today, is that they rely on us as the viewers of the dashboard to come up with a mental model that intersects all those little pie charts, bar charts, line charts, colors, blinky lights, and all that, and somehow figure out what's going on. So that puts a tremendous, tremendous cognitive load on us, and also requires long, long training and experience and lessons learned and probably failures to actually be able to do that relational integrated picture from all the little pieces that go on the dashboards. And of course, they give you zero context. You look at those charts. Is that about the weather? Is that about a nuclear plant? Is that an ER operation room? What is it? I have no idea. It's just beautiful green and red, and it's just pretty, but I have no idea what they represent. So to me, those are big issues, and this has been sort of my thing in the last few years when I give talks like this, especially when we meet on things where we talk about XR visualization, because we need to snap out of this, okay? We need to wake up and snap out of this. Use it when it really is meaningful and valuable, but don't push it when it's actually creating more confusion, okay? So then what are we actually missing? So this is what we're missing. This is how we work as humans. We are social animals. We like to interact with each other. We like to put our hands on things. We like to see, what about this, what about that? Oh, I have this idea, I'm thinking this way, you are thinking that way. So we like that. So really what we're missing is this. We need to be able to leave the real world, and we need to enter the digital space. We need to go there and be with our data in there. And that's what we all as an XR community have a tremendous power in today's society, that we can really have a pretty big impact on shaping the future of all this digital world that we are accelerating. So first of all, if we are using visualization in an immersive manner, it's going to put that information in context. In this particular case, you see some veterinarians, they are studying a horse. The horse has some problems, but now they're looking at the horse on its full environment, different external influences that might have or something. So it's that they're looking at the problem in context. Similarly, if I'm looking, for example, at a factory, now I can be in the factory. I can see this machine is having an issue. I should have a worker over there, and my worker is not here. I'm not sure what's going on. I'm supposed to get 3 truckloads of product out the door, and I only have seen 2 or 3 in the last hour, so something is going on. So suddenly everything starts having a lot more meaning because it's in context. Obviously, because it's immersive, we have a lot more real estate, so we have a lot more information that we can put, with the challenge of what is going to be that information representation. This particular image is a HVAC engineer, so it's actually doing a final test on a digital twin of the HVAC system of a very complex building. So integrating feedback from the sensors in the building combined with some simulations, he's starting to realize, hey, my flow of air is actually pretty uniform, my temperature is very well spread out, so actually the design that we are doing is actually operating like we were expected to operate, so I can validate my design. Of course, it gives us a lot of interactivity, so it's both input and output, so I can see, I can receive digital information, I can inject information into the system, so I can actually have a very dynamic interaction with the data. And another thing that sometimes we tend to forget, again with my thinking that we can no longer think one size fits all when we do digital technologies. If we have immersion, if we have visualization, if we have interactive manipulation of the information, it actually allows us to do a lot more personalization, a lot more customization, and very importantly, target those to the roles of each one of the users. Because sometimes you have many users in an application, but they all have to work with the same system. And the roles might be different. So they might have to have different controls, even different visualizations, different levels of fidelity, different levels of details in their simulation. So that gives us tremendous opportunity, again, as an SR community, to start thinking in this way. Though another thing that I also like to talk about very briefly is that for me, XR is a continuum. I don't really make a difference. This is VR and this is AR, or virtual reality, augmented reality, because people tend to say, hey, virtual reality are entirely digital worlds. You create something digital, you do some kind of display, to some extent disconnect the user from reality, and it's all digital. Then we define augmented reality as I'm grounded on the real space, in the physical space, and I have some sort of digital or virtual enhancement of that real space. I don't really make that hard differentiation, especially when I think on terms of user roles. I might have users that might be, they have to be entirely digital in an application, but other users might need to be AR. Example, I have a bridge inspector, a civil engineer that has to go out there and inspect some bridges here in the bay. Now, that person is going to be walking the bridge and is going to be looking for any anomaly, any damage, any variation to the pattern. So that person is probably going to need an AR system. As he or she is looking at the bridge, there is going to be digital information that maybe is helping that person to say, hey, check on this, check on that, this is a weak point, this is a whatever point. Now, while that person is inspecting the bridge, there might be a bridge engineer back in headquarters that is actually following what this person is doing on the field. Now, that person is going to need to be fully immersed. It's the same application. They are both looking at the bridge, but one is actually on the field, focused on something. The other one is in headquarters looking at the big picture. So those are two different roles, same application, but you need completely different interfaces. So to me, I really think about more on terms of really how we can use the technology to serve the context on which the users need to operate. Or, as we more commonly say, it's about the experience. But I focus on industrial applications. I do very little entertainment. So my experiences are how I can be productive, how I can be safe, how I can be effective. So it's very important. This picture is another example. So you have on the left, you have a doctor is using AR, is superimposing the patient's data, and is looking at it. And for that doctor, AR works very well. Now, the one on the right, you can see now 3 doctors are actually on an immersive representation of the same patient discussing the case. And those 2 can be working together, because the one that is with the patient might be actually pointing something that the ones remotely are actually starting to pay attention. So to me, it's more that gradient. Another biggie for me is what we're living today, that XR, when we say XR, boom, headsets, we're done. Congratulations. Okay, let me tell you another example that I give everybody. How many shoes do you guys have at home? Do you have 1 pair of shoes in your house, in your closet? Why do you have more than 1 pair of shoes? You probably have your shoes to go to the gym. Maybe you have your shoes to go to work. Maybe you have, especially as girls, the highest stiletto heels when we go out on a Saturday night. If you do any other kind of activities, you might have something else, okay? Why don't we do that in XR? Headsets are my stiletto shoes, for example. Am I going to go scuba diving with my stiletto shoes? I probably need fins. But that's exactly what I'm doing right now. This is the world perception of XR. They are equaling the concept of being immersed with a very specific implementation of being immersed. And to me, that's a huge problem that prevents us from making true innovation and progress. Don't take me wrong. I like headsets. I use them all the time. But same as my closet, I'm like Imelda Marcos. I have like 300 pair of shoes. I have 300 different kinds of displays in my lab. Because we focus on who needs to go to do the work, what kind of work they have to do, where do they have to do the work, how long do they have to be doing that work, and many other parameters. And in some cases, the answer is, hey, a headset is perfect, so let's do this project with headsets. In some other cases, a headset is not going to work. We have to use something else. So if anything you take home from my talk, this is what you're taking home from my talk. Think about the technology that is going to place you there, whatever that there is going to be. That's really the main point of my talk. So one of the reasons why people know me around the world is because I asked those questions to myself back in 1991 when I saw VR. Because in 1991, VR was exactly like it is today, headset explosions. So as I was looking at all that, I was fascinated by the technology, and I was fascinated by the concept of that technology, that motivated that technology. So then I developed this alternative, not a replacement, an alternative that is called the Cave. And for those of you that have never seen one, this is exactly what it looks like. It's a projection room, floor is projected, walls are projected, ceiling is projected. It's 3D, so for those of you that have gone to the amusement park, like the Disney's and the Universals, they have a lot of caves in the attractions. And as you can see, it's a very natural way to immerse yourself. So you have there 3 different people. So one is the architect that designed, this is a zoo pavilion that we did for the Tulsa Zoo. And he's actually now checking with some of the safety engineers, and he's checking with the visitor coordinator, trying to figure out, hey, we designed these things, and there might be tripping hazards, there might be, I don't know, fire safety problems. And as you can see, they're having a very easy, very comfortable, in and out natural conversation, where if you try to do something like this on a headset, it becomes extremely complicated and also very difficult to control who is looking at what. Where in here, it's just like here. I point and everybody sees me pointing at something so they can follow the conversation. When I did the Cave a long time ago, back in 1992, it opened a wide range of domains for XR, primarily in industry. Industry was very cautious to get into VR, but when the Cave and the Cave derivatives came out, industry jumped at it tremendously. It did not become very public because there was a lot of competitive protection to what they were doing, but oil and gas industry, automotive industry, pharmaceutical industry, real estate industry, of course, anything related to healthcare, even, of course, military training and military mission planning and many of those things, they jumped on this tremendously, and still today is still being used, but in a quiet, much more quiet manner. But then we come to 2012 and the Oculus. So now it's almost like we hit rewind. So suddenly, VR was back on the public eye. It was on the cover of all the magazines. It was all over social media. And it's wonderful because that's why we are here all today. So thank you, Palmer, if you're listening. You know, this is great that you did this for us. You know, but then, this is what we have as our landscape of XR today. We have a wide range of products, primarily headset-centric. But then, you know, I'm looking at these other products as well. So what are those? Oh, boy. Look at that. So here we are, 30 years later, and we are still sending the same message. Young students in the audience, please be creative. Remove the blinders. Use what we have, learn with what we have, but don't limit yourself to what we have. All of you, how many students do we have in here? Hopefully some, yes, yes. You know, PhDs, masters, undergraduates, I don't care. Just open your mind. Think big. Think disrupted. We talk a lot disruptive innovation. We are not being disrupted in XR. We are not. And you can throw tomatoes at me, but we are not being disrupted. Since the Oculus came out, we've been doing more of the same. Better, of course, better, better. Oh, come on, you know, we have wonderful headsets out there, wonderful technologies. So we've been improving, but we have not been disruptive at all. We need to go back to the 90s and be disruptive. I don't know what the new revolution that I caused with the cave in the 90s could be on the 2020s, but it hasn't happened. We have to do that, because otherwise we're not gonna move forward. We need to move forward, okay? So another thing that we're missing for innovation, because we are so focused on the existing technologies, we are leaving behind complexity. Are XR applications complex? No, I'm not. They are not. They are beautiful, gorgeous 3D spaces with some physics to them. But what is my computational fluid dynamics in XR? What is my final element analysis in XR? What is my real-time weather visualization in VR? Ain't there. Ain't there. So if we get out of the entertainment realm and we really want to put it on an industrial setting or on an advanced education setting, we need to bring complexity back to the VR systems that we don't have right now. So, I mean, there are some issues too, and I know there are some industry people here that might not agree with me, but you know, right now we are very market-driven. We have to put something in the market every so often, and it's very market-driven, which is very good for industry because that forces you, industry people, to really push your technologies and make them faster, make them more compact, make them more affordable, and that helps us. But as academics, we are falling on these market cycles, which we shouldn't. That's the responsibility of industry, and they're doing fantastic with that. But we are almost falling behind. We're just sitting there waiting and see what's the new technology that is coming out. And then based on that technology, let me see what I can do with it. Why? We are in universities, we are in research labs. We can put things forward ourselves that can be just prototypes. And hopefully some of these very talented industry people will pick up our prototypes and turn them into products, okay? Hello? I'm not sure what happened. I'm frozen. I'm not a Mac person, so, okay. Here we are. Okay, I'm working. All right. So, but the fundamental issue when I talk about complexity is the majority of the headsets that we have in the market today are self-contained. What do I mean by self-contained? The display is your computational platform. And because the display is your computational platform, what do we have? Something kind of with this computational power. So there is very little heavy-duty computations I can do in here when I move into the industry realm. So how do we get out of that? We need to be able to bring resources to our display and actually make those environments much more complex, okay? We are starting to have more sensory things, but we still need a lot more sensors into our world. And because we don't have enough computing power, the majority of the industrial applications that I see and the scientific applications that I see, they use VR as a post-analysis. So they do all their science, all their engineering, save all that data, and they do a post-visualization in VR. But if there is some issue, then that has to go back, recompute, re-whatever, and then we go back into VR. So that's a very long turnaround cycle to do that. So we need to change a little bit of that. You know, so VR and XR can no longer be an afterthought. It has to be integral part of the design of whatever it is that we're trying, whatever problem we're trying to solve. The visual, getting the user into the digital space has to be integral part of the design of the solution, not the afterthought as the display. Some other challenges that we have is because we are also data-centric because of AI, because AI needs a lot of data. We keep forgetting that, yes, data, of course, is very important. We need to use AI, and I use it a lot. But, you know, we still need computations. We'll need still processes. We still need a lot of other things that are not necessarily data. Like, for example, we have a project right now that it was stuck because the majority of the team in our project was AI people, and we didn't have any data. So the AI people were like, oh, no solution. And I'm like, wait a minute. Can we actually understand the problem, come up with some computational simulation of the environment, and see if we can do something on that level? Oh, OK. So that's a big challenge, again, that at least in my world I see often. So we need more imagination, like true imagination, creativity, you know, really be curious. And like I said, remove a little bit those blinders that we have in today's world of XR. So here is a quick example. I know I'm out of time. Quick rewind to 1995. This was part of my PhD thesis, guys. I'm turning 60 next Friday, by the way. I'm very old. In 1995, what I was doing with the cave, I wanted the cave to be useful for scientific discovery and for industrial processes and workflows. So this issue with complexity was a big issue. So on those days, of course, we had monsters machines. So this is, some of you might remember this. So this was 1995. I had a cave in San Diego, California. And that was also the time where we were trying to find something that either will cure AIDS or at least slow down the progression of the AIDS disease. So I was working with molecular biologists at Argonne National Labs, and the biologists were telling me, hey, our biological intuition tells us that certain molecular structures could be good candidates for an AIDS medication. But the laboratory time to sort through all these molecular structure is going to take us years. Because, I mean, they have to do whatever they do, Petri dishes and centrifugal machines and all that kind of stuff. So the project that I work with them is, OK, at that time, they already knew the molecular structure of the AIDS virus, the primary protein. And then we had a long list of potential molecular structures that will neutralize AIDS. So what I do is I use all the supercomputers in Argonne National Labs, all the supercomputers in the Cornell Supercomputing Center, all the supercomputers that were on the National Center for Supercomputing Applications in Illinois, and all the supercomputers that were in San Diego. So altogether, I have pretty much the entire high-performance computing infrastructure of the United States running in real time the process of AIDS as it propagates through the human body. And then in the cave, I had the molecular biologists having, on one hand, I have the AIDS, the protein that represents the virus, and I got a bucket of drugs. So I'm grabbing one drug, and I'm just trying to dock it. And docking is the process when a drug actually works. So I just go and I dock it. When I'm docking it, I have the full physics simulation of that process. So very quickly, doesn't work, gone. It could work, maybe goes to the lab. Doesn't work, doesn't work. And in 2-3 days, they reduce from 100, 150 drugs to 10. That's manageable in the lab. And that's what you saw, very quick breakthroughs. I mean, my work was partially contributing to that. Obviously, it was not the one that made the solutions. So this was 1995, guys. That was 30 years ago. Nobody's doing this in XR right now. And we don't need these monster computers anymore. We need some serious computing. But nobody's doing that. It's network optimization, it's parallel computing, it's whatever, whatever, whatever. But we need to bring that complexity into the XR because, you know, I don't know why we are not doing this right now. Because we need to create this kind of scenarios. Here is the same application in the classroom with the experts, with the medical students studying at home, you know, with the patient. Some other example, military, so you have the field commanders, you have the soldiers on foot, you have the situation room in Washington, D.C., you have the drone operators. We need to bring all these things together, you know. Other things that we can do right now, so we have a human digital twin, it's a cognitive digital twin, so you can actually have pretty smart conversations with him, but we have a big computing engine behind it because it's checking on your emotions, it's checking on your situation, so it understands the room that you are, people coming in, people coming out, it's dark, it's light, whatever is happening. So we have a lot of computing behind it. This is some new display that we are working on as well. I do some art work. I don't know if it will play. So this was embedding VR on the stage. Let me see if I can advance it real quick just to give you a little test of it. So on this one, we put 3D cameras on the theater, and we are picking up the dancers, and then we're generating the props as we go. So this is just a little taste of my current work. There we go. We're doing some immersive features. This is pretty cool. We instrumented a boat in Cape Canaveral with a 360 camera and a bunch of other things. And then we have a cave in one of the science museums in Orlando. So we go live 2-3 times a day. So people go on the boat and the kids are in the museum. And it's bi-directional, so the kids tell the person, hey, what is that island, or what is that thing splashing on the water? And then they go and go with the boat in there. And then we also have a thing where whatever they encountered on the field, we send it to them as three-dimensional objects. So then the kids get to play with the oysters or the crabs or the dolphins or the pelicans as they see the people on the boat in Cape Canaveral. So I sort of place them over there. You know, I've done tons and tons of things in my career and all that. But to me, the main point, just to wrap up my talk very quickly, is especially since we are focused on the students today, you know, be truly disruptive when you think on your research, when you think on your ideas. I don't even say think out of the box, because I don't even have a box when I work. Really look around the world around you, look at the people around you, understand the situations on where things are happening, and then let your mind fly, because it's really very exciting times. I mean, back in the 2006, 2007, everybody thought that XR was dead and it was not coming back, and it's back strong. So let's keep it strong, and let's keep it growing, and let's just do amazing, okay? Thank you.